absolute values, inequalities, square roots and radicals, a little bit of everything. Everything we've covered is going to be included in your final. So let's look at question 2. And question 2, we're going to solve this with substitution. And how does substitution work? Well, substitution, you take one variable in one of the equations and you plug it into the other one. Now, why is substitution going to be better in this case than elimination? Well, elimination, you need to have the x's and the y's lined up. In this case, we don't. It's been solved for the x. So substitution is going to be the easier way to work these out. So we're going to plug this back in here. So we're going to plug in x, and that's going to give me, plug it in, 11y minus 10y equals 8. So 11 minus 10, that leaves you with a y. So y equals what? 8. Now, that's only half of it. We have to get the other half. How do we get the other half? How do we get the x value? Well, we take our y and we plug it back in. Does it matter where we plug it back into? No. This one's going to be easier, so I'll plug it into my second equation, and that's going to give you x equals 11 times 8, and so x equals 88. And what's your answer as an ordered pair? Well, the answer as an ordered pair would be 88, 8. Okay. That is going to be your answer now as an ordered pair. And you could check if you wanted to. How can you check? Remember, this is your x and this is your y. Well, let's check here. If I plug it in, x is 88. Okay, so that's going to be 88 minus 10 times 8, that's 80. 88 minus 80 leaves you with what? An 8. So we know it works. That one gave us a solution. Question 6 is a little bit different. For question 5 and 6, it says, solve the system of equations if the system has an infinitely many number of solutions. Give the solution with the arbitrary y. Now, we did one of these last time with the arbitrary x. This one says arbitrary y. So that means we have to solve it for x. So we're going to start off and we're going to see if we have a solution or not. So question 6, that is 2x plus 5y equals a negative 7, and minus 6x plus 15y equals a minus 21. Or sorry, positive 21. Let me make sure I get the signs right here. Just make sure it's easy to copy these down incorrectly. So let's make sure we have 2x. So easy to make a mistake with these. We've got 2x plus 5y equals that negative 7. Next equation, this is question 6 from your homework, minus 6x minus, I made a mistake here, minus 15y. Sorry about that. It's easy to copy something down wrong. So minus 15y and a plus 21. Now, does it matter which variable we eliminate? No. So, why don't we eliminate for x? And if we eliminate for x, this has a negative 6. 2 times what number makes it 6? Well, 2 times 3 makes it that 6. Now, we need to make sure that one of them is positive, one of them is negative, which it is. So we're going to try to eliminate for the x. You can also use substitution. It doesn't matter. Either way. So we're going to distribute through, and that's going to be 6x plus 15y equals negative 21. What about the second equation? That's a minus 6x minus 15y equals 21, right? What happens if I add these together? Those cancel, those cancel, those cancel. What do we have? 0 equals what? 0. And what is that? Is that true or false? Does 0 equal 0? Yes, this would be true. Okay, so that's true there. That means we have an infinite number of solutions. And it tells you specifically which variable to solve for. Now, the ones we did in class, we used an arbitrary x. This one wants an arbitrary y. So that means when it's arbitrary, that means we solve for the other variable. So the ones we did, we used an arbitrary x, right? Those are in the directions. We did an arbitrary x. This one's an arbitrary y. So that means for this one, we're going to have to solve it for the x. So we're going to have to solve this for your variable x. Doesn't matter which equation. You can just pick one and solve it for that variable x. Okay? So let's just start with our first equation. They're the same. You just pick one of them. So we have 2x plus 5y equals a negative 7. We're going to solve this for the x because it says arbitrary y. So that means we solve it for the x. Okay? That leaves you then with 2x equals minus 5y minus 7. We divide by our 2. And now we've got x equals a negative 5y minus 7 over 2. And what are we doing? Writing up our answer with an arbitrary y. So whenever it says arbitrary y, we have a y there. When it's an arbitrary x, you have the x. It's all in terms of the variable. So this one, arbitrary y. And what was x in terms of y? Well, it was minus 5y minus 7 over 2. So make sure you solve it for the correct variable from the directions. In this case, it said arbitrary y, so we solved it for the x, and y was just itself. Are there any others to look at? Anything else? So yeah, make sure you follow the directions. The one we did in class was an arbitrary x. This one was an arbitrary y. So there is a little bit of difference, and that's the only one that's like that. Now, let's go ahead then and start 5.3. And so in 5.3, we're going to be looking at determinants. And we're going to be using what's called Cramer's rule. So we're going to be using determinants, and we're going to be solving equations using Cramer's rule. So I'm going to show you Cramer's rule from our textbook, and then we'll talk about determinants and how those work. So Cramer's rule is in 5.3, and I'm only going to give you two variables. Now, Cramer's rule talks about determinants. And I'm going to show you how to use this rule here in a moment. But this is on page 565. And this is for two variables. We use what's called Cramer's rule. So you have to find dx, dy, and your master determinants below. And you can see what they are. And again, we'll talk about these here in a moment. This is our ultimate goal, is to use Cramer's rule. Now, before we can use Cramer's rule, we need to learn a little bit about determinants and how these determinants work. And what a determinant is it's just a number. And whenever you have, they look like giant absolute value bars, that's a determinant. So I'm going to make up some, and we're going to find the determinant. So we're going to find the determinant here. We're going to start off with a very easy one. About 3, 4, 6, and 2. Now, when it is a two-row, two-column determinant like this one, you cross-multiply. So you cross-multiply and you subtract. So we simply write this as you cross-multiply 3 times 2. Then we take off the upper side. So it's 3 times 2 here, minus 6 times 4. 3 times 2 is a 6. 6 times 4, that's a 24. And when we put those together, we have 24. Right? And a minus 6, that makes it a, watch your signs, negative 18. So you just cross multiply and subtract. Let's do another one. Again, we're just finding the determinant. And how about 8, negative 2, 5, positive 4. So this is our determinant here. And I'll just draw the arrows. Maybe they go up. And when they go up, you subtract. So we have, watch your negative signs here. 8 times 4, going down, minus. Now be careful with the negative. So we subtract off what comes up, and that's a negative there. So we're going to take then 5 times that negative 2. Okay, so it's just down and then subtract up. And we've got 8 times 4. Well, 8 times 4 should be that 32. And watch your signs here. Negative and negative makes it a positive. 5 times 2, that makes it a 10. Putting them together, your determinant then is 42. Let's do another one. We're going to be looking at a 3-variable one in a moment. We're at 3 rows, 3 columns. Right now, we're just going to focus on 2. And when we look at the 3s, we break them up into 2s. So let's do one more of these. And let's see what this would be. That's going to be 5 times 9 minus 0 times a negative 8. 0 times anything is 0. So 5 times 9, well, that's a 45, and that's 0. So your answer would simply be 45. Now, when we look at determinants that have 3 rows and 3 columns, then we have to look at cofactor expansion. And so we're now going to try one that has 3 rows, 3 columns. It's 3 by 3. 3 by 3. 3 rows, 3 columns. So when you have 3 rows and 3 columns, we are going to break this into 2 by 2s and break them down. Now, when we look at this, we have to either expand across the top or we expand down the side. If we have zeros, we expand that way. If we don't, then we can either go down the side or across the top. Now, how the signs go either way is they go plus, minus, plus. So it doesn't matter which way we go. If you have zeros, like if I had a 0 here, I would definitely want to expand across the rows instead of down the columns. You can expand wherever you would like. I'm going to go ahead and just expand down. Well, we'll expand across the column. If it'll be easier to do, doesn't matter. You can either go down or across. Or even on the diagonal if you really wanted to. We're going to go ahead and expand across the top. So what we do is we figure out where we're going to start at. So I'm going to go across the top. So let's start with a 4. Okay, so this is going to be 4. So that 4 goes out in front. And then I cross out where that 4 is. So I cross out that, and that leaves me with a 2 by 2. Okay, so you see how it is here. You cross that out, cross that out. What does that leave you with? That. So what's left over? This determinant, which is 1, 4, 2, and 5. And we've used that 4. Now we go to the 7. Now what's in front of the 7? Well, if we look up here, it's a negative. So negative 7, because that's your sign. You always go plus, minus, plus. So we're going here. We're just going to go across the row. We had a 4, so that gave me that when I covered that up, right? Now, we cover up for the 7. If I cover up for that negative with that 7, our sign's negative here. If we cover it up, what's my determinant? 5, 4, minus 2, and 5. So my determinant when I cover this up, so that's what I've got left. So I covered it up. So what's left over? We have a 5. We've got a 5, 4 across, minus 2, and 5. Is everyone okay with how I did that? Now, what's the next one? Again, going across. So there's my 2. Cover up the 2. And by the way, the sign has a positive, so that's a 2 in front. And let's cover it up. If I cover that up, what's left over? This determinant. 5, 1, minus 2, and 2. Now we do each one of these individually. Put them all back together, and we're done. So we're going to do each one of these individually. So let's look at this determinant. So let's try this one. We've got 1, 2, 4, and 5. We just did these a moment ago. So what do? Cross and subtract. So that determinant would then come out to be 1 times 5 minus 2 times 4. 1 times 5 is a 5. 2 times 4 is an 8. And it's a negative. So that leaves you then with a negative 3. Let's do the next one. We'll do all 3 of them, and then we'll put all the pieces back together. So let's do the one that's in front of the 7. 5, negative 2, 4, and 5. Cross and subtract. So that's 5 times 5 minus, watch your signs here, minus 2 times 4. So you've got to be very careful with those signs. Where students make a mistake is that double negative, because this is always negative. So 5 times 5, well, that's 25. Double negative makes it positive. 2 times 4 is an 8. And you'll add those together. 25 plus 8, well, that is a 33. So we'll come back to that in a moment. We've got one more determinant to work through. And we'll put it all back together and finish it. So what's my next determinant? 5, 1, minus 2, and 2. Cross and subtract. So 5 times 2 is 10. And I'm not going to write up the numbers again like we've been doing. I can just mentally do this. Now watch it when you subtract. Minus 2 times 1. That's a minus 2. Change the sign, makes it 4. Putting those together, I then get my 14, right? Now, put all the pieces back together. Then we're finished. First one, we did it here. That was a negative 3. What's in front? 4. So that is 4 times that negative 3. The next one. That's this determinant. We did it here. What's in front of it? Negative 7. So that's negative 7 times 33. And I'll move it up so you can see it in a moment. What's the last one here? 2. I want you to be able to try to see all of it here. So there's 2 in front. And what was that last determinant? 14. So now we just multiply them together. Finish it out. 4 times a negative 3, that's a negative 12. 7 times a 33, it's a negative. So that makes it a negative, multiply here. 33 times 7 makes a minus 231. 2 times 14 should be a positive 28. Put them all together. 12, 231. Minus that 28. That makes it a negative 215. Now, that is more complicated than most of them that you're going to have. Anytime you have some zeros, it's a much, much easier problem to do. The only reason why we had to do all 3 pieces was because we had no zeros. If you have zeros, that's where you'll expand across. It's going to save you some time. So let's do another one. This one's going to be easier. And why it's going to be easier is because of the 0. We always first keep track of the signs. So how do they go? They go plus, minus plus, plus, minus, plus. That is how they go. So this is called cofactor expansion. When you do cofactor expansion, that's how the signs go. Plus, minus, plus. They always switch back and forth. I am going to go down the side. Why am I going to go down the side here? Because there's a 0. When we have this 0, that means we don't have to do that determinant. So instead of having to do 3 of them, you're only going to have to do 2 of them. If you went across the top, you would have to do all of them. So that's why whenever you have a 0, you want to expand around that 0. So let's go ahead now and expand down the column. So we're going to start with a 5. Okay, we're going to do the same process. Cover it up. So we know we have the 5 in front. So we put the 5 here, and it's positive 5. And let's cover it up and see what we have. If I took the 5 and I just covered it up, what does that leave you with? 8 and 2, 7 and 3. So that's our determinant here. It's going to be 8, 2, 7, and 3. So there's that piece. Now we do it again. This time, we're going to cover up that 0. What's in front? Well, that 0 was in front, right? So that's there. And then what's our determinant? Our determinant is going to be 2, 1, 7, and 3. What's our last one? Going down. We did that one. So we'll do this 2. Okay, so watch your signs here. 2 is going to be there. It's positive. And what is that determinant? If I cover up that 2, what does that look like? Well, that determinant looks like now 2, 1, 8, and 2. We don't have to worry about this one here because this one has a 0. And we know 0 times anything is what? 0. So we don't even have to calculate it. That's why you want to expand around the zeros, because it's gone. Right? Doesn't matter. 0 times anything is just 0. Now let's work out the 2 determinants that are left. So we've got, for the first one, 8, 2, 7, and 3. So just simply cross here. And you can work this out mentally. You can write it out if you want, if you need to. We've got 8 times 3. Well, 8 times 3, that is a 24. And 7 times 2, 7 times 2 is a 14. We subtract it off. And that leaves you then with a difference of 10. So there's that piece. Next determinant. 2, 1, 8, and 2. Cross again. So 2 times 2, 4, minus 8 times 1, which is an 8. 4 minus 8, that's a minus 4. Putting them back together, what do we now have? We have 5 times 10. That determinant is there. And then we have a plus 2 times a negative 4. That's that determinant. We didn't have to do that one. Why not? Because that was 0. So always be careful how you expand. What does that give you for your answer? Well, 5 times 10, that's 50. 2 times a negative 4 makes it a negative 8. Putting those together, we are left then with a positive what? 42. That's it. And that's your final finished answer. Okay. Let's try another one. When you work these out, always try to find the zeros, and you always expand wherever there's the most zeros. You can expand on the diagonal if you want. I usually do not. I either expand across a row or a column. Bless you. Okay, so let's say I give you this one. And I made my lines a little bit long here, but that's okay. So didn't need to make them that long. Now, where would you expand? Would you expand down or across? In this case, you want where it has the most zeros. I could expand down. But if I expand it down, there's only one 0. Okay? I'm going to expand across because there's what? 2 zeros. How do the signs go? Plus, minus, plus, or plus, minus, plus. Okay, let's expand across that row. So let's work with a 4. So we have a 4 in front. And cross these out. What's left over? 1, 9 minus 2, 6. So I just cross out that 4. 1, 9 minus 2, 6. Next one, we'll write it out, but it's really not even needed because the next one has that 0. But let's go ahead and write it out anyways. If I cross that 0 out, we're going to cross the row here. If I write out this determinant, what is it? It's 7, 9, 0, 6. And that was actually a minus there, so make sure you watch the signs. But minus 0 doesn't even matter, it's gone, right? 0 times anything is 0. And what about the last one? What would it be? It would look like this. It would look like 0 out in front. We've got a 7, 1, 0, negative 2. Now, why is this one so easy? Well, this one's so easy because, look, that's gone, right? That's gone. So I only really have to do one of them. So let's work it out and put it back together. 1, 9 minus 2, 6. Cross here. 1 times 6, that's a 6 minus, watch your signs, negative 2 times 9, that's negative 18. Again, be very careful of the signs. Double negative makes it a positive. So 6 plus 18, that's a 24. What's our answer going to be? It's going to be 4 times 24, which is then what? 96. And that's it. That's all you have to do. Now, we're going to use this to get Cramer's rule. Cramer's rule is another way of solving systems of equations. And Cramer's rule is how a computer calculates systems. So a computer is going to use Cramer's rule. We usually use elimination. Or in some cases, substitution. The computer, though, will always use Cramer's rule because it's very calculational. For Cramer's rule, we've got to find these different determinants. So Cramer's rule is back here on page 565. We're going to talk quickly about Cramer's rule. And Cramer's rule is for something like this. Ax plus by equals c. And then I'll use the same variables they have. Use ones. And then we've got a 2x plus b2y equals c2. Okay, so it needs to look like this. This is Cramer's rule. So, just like the quadratic formula, we had to have a starting point. Cramer's rule is the same. It needs to look like this. Now, we need to find all these different pieces. So we need D. And D is another determinant. And D is the x's and the y's. We also need dx. And dx, we replace our x with the c. So that's going to be the c and the y rows and columns. And then we need dy. And dy is going to be the x, and we replace the y with the c. And then how we find our variables is x is dx over d, and y is dy over d. Now with two variables, this is actually pretty easy. If I gave you three variables, which I won't, three variables would be a long process. The more variables, the longer it's going to take. And they expand exponentially, so it's a lot more work to do three variables than just two. So I'm not going to give you any that have three with Cramer's rule. It's just too time-consuming and too easy to make a mistake. So I'm now going to pick a couple of these from our textbook to look at and work through. And we're going to be using Cramer's rule. Okay, so let's try a couple of these with Cramer's rule. And if you want to follow along in the textbook, you can. Otherwise, I'll just write them up on the screen. So we're on page 569. We're going to look at question 65. And we're going to use Cramer's rule. So we're going to be solving this with Cramer's rule. And we have 4x plus 3y equals a negative 7. And we've got 2x plus 3y equals a negative 11. Okay, so we write these so it looks right here. Okay, so this is going to be using Cramer's rule. First off, it needs to look like this. So are the x's on top of the x's? Y's are on top of the y's, and numbers are on top of the numbers. Does that look like what we've got here? Yes. Okay. So this is your x, this is your y, and these are your c's. So we've got to find our three determinants. So let's start off with our master determinant, d. D is your x and your y. And what numbers do we have for the x and the y? We have a 4, 3, 2, and 3. So find this determinant. 4 times 3, and you can write it out or do it mentally. 4 times 3 is 12 minus 2 times 3 is 6. 12 minus 6, that's a 6. So we've got to keep track of that. Okay, so that's our first piece. That's our D. Now, we also need dy and dx. So what's dx going to be? Well, dx, we replace the x with the c. So what's our c's? Our c's here are minus 7 and a minus 11, right? Let's double check and make sure we copied everything down correctly. So minus 7, minus 11. What's our y's? 3 and 3. Cross multiply. Or not cross multiply. Draw your x and subtract. So when we do that, what do we have? Well, we have a minus 7 times 3. That's a minus 21. Now when we multiply up, what do we have? Bring up your negative here. Minus 11 times 3. Minus 11 times 3, that's a minus 33. We know the double negative makes that now a positive. And so we have a negative 21 plus positive 33 and that gives you the 12. We'll get the actual values of x and y in a moment. I always like to just get the determinants first. So now let's get dy. So dy is going to be x, and the y is what gets replaced. Y gets replaced with the c. So what are our values now? Well, 4 and 2 for the x. C is over here, minus 7, minus 11. Draw your arrows and subtract. So 4 times a negative 11, that's a minus 44. Watch your signs. Minus 2 times a negative 7. 2 times a negative 7, that's a minus 14. Again, be careful of your signs. There's always a negative in between. The double negative here makes it a positive. And now we've got a negative 44 plus 14. That comes out to be a negative 30, doesn't it? Now we've got all of our determinants. Now we can quickly and easily get our answer. What is x going to be? X is dx over d. dx was 12. D was 6. 12 divided by 6 is a what? 2. What about y? Y is dy over d. What did we find dy to be? Negative 30. What was d? Positive 6. Divide them out. What do you get? Negative 5. What's your answer? As an ordered pair. Ordered pairs go x, y. So as an ordered pair, that should be positive 2, negative 5. Is everyone okay with how I did that? We'll do another one. Let's do a couple of these just to make sure. They're a little bit time consuming. So let's look at, how about 67? Okay, we'll try 67. Okay, so 67. 67, again, we're going to use Cramer's rule. And we've got 5x plus 4y equals 10. And we've got 3x minus 7y equals 6. We could solve this with either elimination or substitution, but the directions specifically say use Cramer's rule. This is your x, this is your y, and this is your c, the way I label them. We always start off with our master determinant d, and that's your x and your y. So that's 5, 4, 3, negative 7. Cross multiply here. 5 times a negative 7. That's a minus 35. Minus, always bring your negative down. 3 times 4. 3 times 4 is a 12. Those are the same sign, so they add together. So that makes it a negative 47. Let's make sure that I copied all the numbers down correctly here. Okay. Make sure it looks right. Yep. It's easy to make a mistake when you copy these down. Negative 7, just to make sure. Okay, we've got 5 and 4, 3 and negative 7 there. So then we took 5 times a negative 7, negative 35. 3 times 4 is 12. But don't forget, there's always a negative here, so that gives you the negative 47. So it looks like we're on the right track. It's just so easy to make a sign error. D. We've got the dx, so d of x. This d has the x here, so the x gets replaced with the c. Y stays as it is. So that would be 10 and 6. Y stays the same as 4 and negative 3. Cross multiply. Ten times a negative 7, well, that's a negative 70. Watch your signs here. 6 times 4, that's 24, and it's a negative. Those are both negatives that go together with addition. And that comes out to be a negative 94. And we could get the x right now. I usually don't. I usually try to get them all, the determinants, then get your x and your y. So let's try dy next. Right? dy would be x, and we've got the y here. So y gets replaced with the c. So the x is 5 and 3. The y is 10 and 6. Cross. 5 times 6, 30, minus 3 times 10 is 30 as well. Don't forget your sign in the middle is negative here. So that gives you a difference of 0. Now we can finish it out without much work at all. Let's get x. X is dx over d. dx was a minus 94. D was a minus 47. Negative and negative makes it positive. So 94 divide by that 47. Negative and negative makes it a positive 2. What about y? dy over d. dy was 0. D was a minus 47. 0 divided by any number is what? 0. So what's my answer as an ordered pair? Make sure you put it in the correct order. That's 2, 0. And that's the same answer that you would get if you used either substitution or elimination. This is part of matrix and linear algebra. And if you go on to engineering or any other math courses, you may take what's called a linear or matrix algebra class that is nothing but different ways of solving equations simultaneously. So systems of equations. There's whole entire courses on these. Different ways of doing them, different things you can do. I'm just presenting you the basics. I think we have enough time. We'll do one more of these. And then I will give you the take-home final to look at. And we'll do maybe one question off of the practice file. So let's try one that has fractions. Well, I don't want to do a 3 by 3. Let's do 68. Because you could do 3 by 3, 4 by 4. If you did a 3 by 3, that'd be x, y, and z. You could do a 4 with 4 variables, but those are so difficult, so time-consuming, that we're not going to cover them. Anything much past 2 variables, you're probably going to use a computer to solve, because it can do it almost instantaneously, and it would take us, if we did 3 variables, it'd take us 15 minutes or more for one question. So why have you do that when it's just computational? So I'm only going to have you do 2 variables, which is x and y. So let's make sure we copied it down correctly. We've got 3x plus 2y equals a negative 4. That's correct there. 5x minus y equals 2. So let's get D, X and Y. So 3, 2, 5, and minus 1. There's no number there, so we know that's a minus 1. Cross multiply and subtract. So 5 times a negative 1, 3 times a negative 1 here. 3 times a negative 1, well, that's a negative 3. 5 times 2, bring down your negative. 5 times 2 is 10. Putting those together, that's minus 13. Let's get dx next. That's your c, and that's your y. So we have a minus 4, 2 for the c. Y is 2 and negative 1. Careful with your signs here. Minus 4 times minus 1. Negative and negative makes it a positive 4. We're going to bring down our negative here. And what do we have? 2 times 4. 2 times 2 makes it a 4. And that gives you then a 0. So dx is 0. Let's now do dy. Put them back together, and we'll be done. So let's do dy next. And that's your x, and we're going to replace y with the equal sign with the c over here. So your x is 3 and 5. C is minus 4, positive 2. Those are our values. Okay, make sure you know how to find them. And then we just cross and subtract. So 3 times 2, that's a 6, minus 5 times a minus 4. That's a minus 20. Double negative makes it positive. And that's 26. So what's our x? Let's try to find our x now. Okay. X is dx over d. Dx was 0. D was a negative 13. So that leaves you with 0. What about y? Well, we did y here. dy. So y is dy over d. dy was a 26. D, if we go up, was at negative 13. And that comes out to be a negative 2. So your ordered pair would be 0, comma, negative 2. And that's your answer. So not too difficult. It's just all calculation. And all you really have to remember is cross and subtract. I'm now going to go ahead and give you your final review packet. This is due on the day we take our final exam. So this is all due on the day of our final. Okay, so we talked about it last time, but I went ahead and printed it off as well. This is your final exam schedule. And your finals at a different day than normal class. You're welcome. Might need it in your other classes. Just make sure you know when your finals are. The finals are at a different time and a different day than normal. I don't want anyone to show up on the wrong day. I know we went over it, but I'm going to go over it again. So this is our final exam schedule. When is our final? When does our class normally meet? Our class normally meets Tuesday, Thursday at 11. So when is our exam going to be? Just so everyone knows. 10 o'clock on Wednesday, May 9th. Right? So make sure you're here at 10 o'clock on Wednesday, May 9th. May 10th for your final. So Wednesday, May 10th. That final review packet that I just gave you, it has two parts to it. There's a practice final, which is the first page. We're going to go over this next week. We'll maybe do one question today. We'll do the rest next week. So this is 15 points for here. Now, if you turn further in, you will see another version of it called the take-home exam. This is worth 100 points. Okay? Make sure you turn this in when you take your final exam. I will grade it, and it's for a grade. It's worth 100 points. It's worth a regular exam. Now, your final on that Wednesday, May 10th is worth 300 points. It's a big portion of your grade, but you are going to know exactly what is on it. Your final exam will have 30 questions. Your practice final and your take-home final have 40. So I'm going to take out 10 questions, and that's going to be your final. Different numbers in a different order. If it's on your practice final, it's on your take-home final, and you're going to see that more than likely on your final exam. Again, there's 10 of them that I'll cut out. So you're only going to have to do 30 questions. How you want to work these out is I would work through the practice final. Now, we're going to go over this next week, and I'm going to give you a detailed answer key of how I did every single question. Then use the practice final to complete the take-home final. Okay, and then once the take-home finals, you got that grade, you'll turn that in, and you're ready for your final on that Wednesday, May 10th. Okay, so what you see on here, on your take-home final and your practice final, they're very similar. That's what you'll see on your final exam. So next week, we're going to be working specifically on nothing but your practice final. We've got a little bit of time left, so I'll probably go through and work out maybe 1 or 2 questions on your practice final, and we'll do more of these next week. Next week, we'll break up into groups. So I'll work out 1 if I have time, maybe 2 of them. Let's work on our practice final. Let's work with question 6. We should have enough time to get through question 6. Your final is going to have a little bit of everything. So it's got applications, graphing, roots and radicals, rational equations, expressions, systems like what we just did, logarithms, exponentials, all of them. We're going to start off with question 6. Find 2 consecutive odd integers whose product is 195. Remember, we did these way back in 1-5. Now, the key word here is what? Odd. So what do we know about odd numbers? What's the gap for odd numbers? Odd numbers, they have a gap of 2. So we call the first number x and the second number x plus 2. Now, what is our equation going to look like? Well, we want to find the product of the two numbers. So that's number 1 times number 2. And that's going to be 195. Plug them in. So that's your x. And x plus 2 equals that 195. And hopefully you kind of remember how to solve this, right? Well, what do we want to do? It's been a while since we've done one of these. We want to distribute that x through and then set it equal to what? 0. So let's do that. So distribute that x through, and that's going to be x squared plus 2x equals that 195. We'll move that 195 over. Now we've got x squared plus 2x minus 195 equals 0. And remember how we would solve these. What do? It's equal to 0, right? So we use what? 0 factor. You shouldn't have to use grouping at all. You take the first number times the last. That's going to be a minus 195. It's negative, so what do we know? Are they different signs or are they the same? If it's negative, they're going to be different signs. So that means one number's positive, one number's negative. And I'll go ahead and pass out the sign-in sheet, because I think this will be the last question we'll look at today. Okay. Just make sure you sign the sign-in sheet before you leave. Okay, we want to try to factor this out. It ends in a 5. So let's try a 5. 5 and 39. Does that give you the 2? Nope. Let's try 15. 15 and 13. Is that difference 2? Yep. What's the sign in the middle? Positive. So that means we need a positive 15 and a negative 13, right? Because those give you the 2 in the middle. We can jump directly to our factors, and so we can jump to x plus 15, x minus 13, x plus 15 equals 0, so x equals a negative 15, x minus 13 equals 0, so x equals positive 13. Now remember, when we look at these, we're going to have two sets of numbers, a positive set and a negative set. So what are the two sets? Our two sets are going to be a negative 15 and a negative 13, a positive 13 and a positive 15. As you're working these out, if you look in the back page of your practice final packet, you're going to see an answer key for that practice final, so you can check them out. You can make sure you did it correctly. Now, next week, I'm going to work out this entire practice exam for you, like we've done before, post it in Canvas so you can see how I did each and every individual question. So that's what we're going to work on next week, is the final. Preparing for that. So, what's your homework? Well, your homework is going to be 5.3. You should be able to do them all. Also, double check your Canvas gradebook. If you're short assignments, make sure I get them. I'll take assignments all the way up until the last day. So you can turn them in with your final. I would prefer that you give them to me early. But if you're missing things, everything has to be done no later and turned in no later than when we start our exam on that Wednesday. Okay, so make sure that you get everything turned in by that Wednesday. Because remember, when's our final? Our class is Tuesday, Thursday from 11. So our final's on Wednesday at 10. So make sure you're there. I'll take everything up until that very last day. Make sure, double check your Canvas gradebook. If you're missing assignments, make sure I get those. I will see everyone then next week.